Hello everyone. In this video we will be solving exam questions from past paper on logic and mathematical reasoning. The first question, P implies negation Q is true given. That means P must be true and negation Q must be false, because the whole implication here it is false given. So the only case in case of implication to be false is premise true and conclusion false. Therefore we can have here P it is true and Q also it is true. We know this because negation Q false means Q is true. And then which one of the following is true? Let us see each choice. Choice A, negation Q and P implies Q. Negation Q, it is false. False and whatever, it's false, so we can ignore. And choice B, negation P or Q implies negation P again. Negation P is false. Again here Q is true and negation P is false, and true implies false, it's false. So false or false will be it will be false. Again it fails. When you go to choice C, negation Q or P by implies Q, it says. Negation Q, it is false, or P is true. The outcome here will be true by implies. Again Q is also true. So true by imply true will be true. That's acceptable. The answer will be C. When you go to the next question, suppose E of x is even, and P of x is prime, and D of x is divisible by 2. Then which one of the following is false? Choice A, it says there exists x, E of x and P of x. What does this mean? There is a the domain is natural number. There is a natural number x which is even at the same time prime. Even and prime. Yes, that number is 2. The number 2 is even and prime, which is correct. Choice B, for all x, E of x implies D of x. What does this mean? Every natural number x, if it is even, then it will be a multiple of 2. That is again true. Every even numbers are multiples of 2. That is correct. Choice C, there exists x, E of x and negation of D of x, it says. What does this mean? There is a natural number x which is even and not multiple of 2. This is false. There is no natural number which is even but not multiple of 2, because negation of D means not multiple of 2. If it is even, necessarily it has to be multiple of 2. But when we interpret this statement, there is a natural number x which is even and not multiple of 2. We cannot find this kind of number. So the answer will be C. The next one, consider the following argument for production is high if the rain continues. Rain doesn't continue. Therefore, either production is low or rain continues. So at the given, let P production is low and Q rain continues. So we have two premises. Production is high if rain continues. This is one premise. We have to connect it. Production is high. This is the negation of P, because P says production is low. The negation of low is high, But which one is the premise here for the conditional statement here? If rain continues will be the negation, the premise. So Q implies negation of P. That is the first premise. And rain doesn't continue. That's going to be the second premise, negation of Q. Finally, the conclusion, either production is low or rain continues. That means P or Q will be our conclusion. The following table also given about P and Q, and which one of the following is necessarily true. So to say this logical argument valid or invalid, we have to check whenever the premises are true, the conclusion has to be true. So where are the premises true? Q implies negation P. Where is it? Here it is. The column, I'll try to indicate the column where it is. This column means the first premise, and the second premise, here it is. So whenever the two premises are true, the conclusion must be true. Where they will be true. As you see here, in this row, the two premises are true. Also the last row, the two premises are true. I'm trying to observe the two arrows here, what are indicated, because the premises are negation Q and Q implies negation P. So at this point the two are true. Better to show by tick true true and true true, the premise true. So at this point, are they valid? To say valid, the conclusion must be true. Whenever the premises are true, necessarily the conclusion has to be true. The first step, it is true, yes, it works. But the last one, the last row, it doesn't work. So in the second step, or in the second row, it is valid here, but the last one doesn't, so it fails. So what we can say, the argument form is invalid because of row number 4. It has to be true for both cases. So we cannot, because of one row, we can't, let's say it's valid totally. We cannot conclude by one row. It has to be true in every cases of premise true, the conclusion must be true. So when the premises are true in the first row here, like in the second row, the conclusion also true, acceptable. But at the last row, the premise is true, but the conclusion is not. Therefore, the answer necessarily will be C. Let us continue to the next question. The next question again, let P, Q and R be propositions such that P implies R or negation Q is false. That means, again, like I said before, in case of implication, to be false, the premise part true, the conclusion is false. So from here you can deduce P is true and R or negation Q also true. But in case of OR, to be false, both must be false. That means R is also false and negation Q must be false. Negation Q false means, Q will be true. That's what we need. Q necessarily will be true. We do have these three truth values of arguments, the propositions. Therefore, which one is true? Choice A. It says P implies R. This means P is true and R is false. Is it true? No, this is false. And choice B, negation R implies Q. Negation R means true, implies the Q is true. True implies true. Yes, it is true. It works. And choice C, negation P by implies Q. Okay, let us change it. Choice C says negation P by implies Q. Negation P is false and Q is true. They are not the same. In case of by implication, the two has to be the same to be true. This is false. And the last one, D, Q by implies R. Q and R, as you see, they don't have the same truth value, so it fails again. This will be false. So the answer will be B. The next one, it says, for real numbers x and y, which one of the following statement is true? Real number, our domain is real number. Choice A, for all x, there is y. X squared plus y plus 1 is equal to 0. What does this mean? You can take any real number x. Okay, for all x there exists y means take any real number x and square it, then add 1. For example, someone can take a real number like 100 or 10. Take 10, square it. 10 squared plus y plus 1 is equal to 0. 10 squared, it's 100. 100 plus 1 will be 101. Plus y is equal to 0. Now, after you take x, because x is free, after you take any real number x and square it and add 1, can you find the opposite of this number? Because the opposite of this number will be added with the y must be the opposite of it to be added and give you 0. So for any real number we can find its opposite, because for all x taken and squared and added 1, the result, it will be a real number. So this real number plus what will give you 0? Obviously the opposite of it. So can we find that opposite? Y? Possible, that is true. Let us see choice B. Choice B says there exists x for all y, x squared plus y plus 1 is equal to 0. What does this mean? You can find a real number x here. You can fix any real number. Always the square of this number, which will be added with every y plus 1, will give you 0 always. You cannot find a fixed real number. This number must be fixed. That fixed number plus whatever you take the y here, because for all y plus 1, okay, the sum must be 0. We cannot find. It is false because there is no fixed number x which will be added with any y, any real number y plus 1. Always the sum will be 0. It doesn't work. When you go to choice C, there exists y for all x, x squared plus y plus 1 is equal to 0, the same like that of B. Can you find a real number y here which is added with, for free x, any x squared and add, and always will be 0? We cannot find one fixed number y which will be added with the sum of x squared plus 1 and the result 0. We cannot find a real number like that. So again this fails. The last one also the same pattern, it doesn't work, so the answer obviously will be A. The next question, consider the following argument. It says, if he doesn't love her, she will not marry him. He loves her, therefore she will marry him. So as a proposition representation, you can take P, he loves her, and Q, she will marry him. Then which one of the following is correct representation of the argument and its validity, it says. So that we have two premises. The first one, if he doesn't love her, she will not marry him, which is negation P implies negation Q. And the second premise, he loves her, that's P. And the conclusion, therefore she will marry him, which is Q. So when you combine them, first premise, negation P implies negation Q, and second premise, P, and the conclusion is Q. So which choice contain this one? Choice A and choice B. But the argument, is it valid or invalid? Let us check now. As a premise, each of them are true, and then we are going to see whether the conclusion is true or false. If P true, that means this is going to be false. Negation P will be false. As a premise, P is already true, here it is, and negation P will be false here. So if negation P false, false implies whatever will be true always, obvious. Okay, we cannot say Q is true or false this time, because false implies whatever will give us the truth. As a premise, it is true already, the implication. But here negation P is already false. False implies whatever will give us true. Therefore we cannot say anything about Q. Q can be true or false, so it is invalid. It's not always true, Q. It's not necessarily. So the answer must be B. When we proceed to the next question, it says P or Q implies negation R and R is true. First of all, what does this mean? Negation R and R. Obviously it's false. So what implies false will give you true? Obviously the first part also must be false. Otherwise, if the premise part, if I take the first part or the premise part true, true implies false will be false, but it's given as true. Therefore we have to consider the premise part here false. Which one? P or Q? It is false. So in case of OR, false means each of them must be false. So P false, Q also false, and R we don't know about R. So which one is necessarily true? Let us see now the choice one by one. Choice A, P or Q. P or Q means false or false. False or false is, it is false. False implies whatever, it is true, because the whole thing is false. False implies whatever, it will give us true. This is necessarily true. But B is false, obviously, because negation R and R is false already. We said it from the beginning. For any two propositions, P and negation P, or Q and negation Q, it is always false. The reason, either of the two will be false. One false is enough to be false in case of conjunction. When you go to choice C, negation P is true by implies, and we don't know about R. We can't say anything. So necessarily we cannot say it is true. If R true, it will be true. If R false, it will be false. The last one, choice D, negation P is true. True or whatever is, again it is true. So the answer necessarily will be A and D. Next one. The next question, it says, suppose that P represents the statement he missed the tournament, and Q represents he got the gold medal, and R represents the statement he took a trip abroad. Then which one of the following is the symbolic representation or expression represent the statement if he take a trip abroad and he does not miss the tournament, then he will get the gold medal. So this time we will simply try to find the symbolic representation or symbolic expression which express the statement if he take a trip abroad and does not miss a tournament. From here until here, but underlined here, it is a premise for the conditional statement, the if part. So if he take a trip abroad means that's R, and there is and he does not miss the tournament, that's negation P. This is all together a premise for the conditional statement. Then he will get the gold medal, implies Q. So which one will be the symbolic expression? Necessarily it will be C. Next question. For arbitrary proposition P and Q, which one of the following is valid equivalence? A, negation of P implies Q. It says it is the same as Q implies P. No. The reason, Q implies P is the converse of P implies Q. But negation of P implies Q, it is the same as P and negation Q. So the two cannot be the same, it fails. What about B? The B one says negation P implies Q, and P is the same as P and negation Q. Let us check. As we said before, negation of P implies Q, the whole negation. It is the same as P and negation Q, and P there. Let us try to complete this. It is and, doesn't matter, no need to write the bracket. So P and P, always P. P and P is P, don't forget that. Because if P true and true will be true. If P false, false and false will be false. So the truth value of P and P will be just P. We can take P and P as P. So P and negation Q remain. This is the same as what is given here. So that is, they are equivalent. So the answer necessarily will be B. Next, which one of the following compound propositions is a tautology? A, choice A, it is Q or negation Q implies P. Q or negation Q, you know it is true. True implies P. We don't know about true P. If P true, it will be always true. If P false, it will be false. So we cannot say it's tautology. To say tautology, it has to be always true without any precondition. But here there is a precondition. We don't know about the truth value of P here. P might be true or false. So this one, it has two possible outcomes, true or false. When P true, it will be true. When P false, it will be false. So it's not tautology. Choice B, P implies. Okay, this is choice B. What I did here is it is choice B. Let us do now choice A. Choice A. Okay, no, it is choice A. This one already. Now choice D. B. P implies again Q or P implies Q or negation Q. Again, as I said before, this is true. If this is true without any precondition, whatever the P1, always this is true. Therefore, that is tautology. So the answer will be B. If you see choice C, Q and negation Q, it's false, obviously. False or P. We don't know about P. P true will be true, the whole outcome. But P false, it will be false. So it is dependent on P. We cannot say it is always true. It's not tautology. The same manner, the last one. Q and negation Q, it is false. It will be false. So what will be P? If P true, it will be false. If P false, it will be true. So still it is dependent on P. We cannot say it is always true without precondition. So necessarily the answer will be B. Next question. If the truth value of a proposition P is false, then which one of the following compound proposition has truth value true? Don't forget, P is false, given. P false, false or false and whatever it is false. Doesn't work. And B, P is false and negation P will be true. True implies false will be false again. Doesn't work. When you come to C, the inner part, it's or. So one of the two is true, obviously. So one true is enough to be true, but negation of true will be false. It fails. And the last one, choice D, P it is false. False implies whatever, it will be true. But actually negation P means it is true. False implies true will be true. Even false implies false also true. So from the beginning, when you see choice D, P is already false, given. False implies anything, it will be true. So the answer will be D. Next one, our universal set here, set of natural number. Which one of the following proposition is true? Choice A, for every x there exists y, x divided by y is equal to y divided by x. What does it mean? X over y is equal to y over x, which means x square is equal to y square. When you crisscross, x square is equal to y square. For every natural number x, you can find another natural number y which will be equal of it. Yeah, you can take any natural number x and square it. Can you find another number y which will be squared and equal to the same as like x square? Yes, because for every x you can take any. X is free. You can take any number first x. Then after squaring, can you find another natural number which will be y square and it will be equal? Obvious, it is possible. So the answer will be A. But let us check the other choices. Choice B, there exists a natural number x. There exists a natural number x. The sum of itself is equal to x. Two natural, like take one natural number, add with itself. Is it the same as the number, the original number? We can't find. It doesn't work. Choice C, for every natural number x, there is y. Y is less than. Remember, x is free. For every x means, what if I take in place of x1? Can you find another natural number y which is less than 1? No, doesn't work. And choice D also, you can check, it's not working. So the answer obviously will be A. The next question, it says for any real number x and y are real numbers, which one of the following statement is not true? A. Any real number x and any real number y can be taken and square them and add them. They are always greater or equal to -1. That is true. Square of a number from the beginning cannot be negative. Even if we take 0, 0, the minimum number that we can take here is 0, 0. Because negative numbers, if you take in place of x and y, when you square it will be positive, obvious. Positive plus positive will be positive. So it's always greater or equal to -1. That is true. Choice B, for all x, there is y. You can take any number x here. In place of x, you can take any number, square it, then add 1. Then the result that you have for this result, can you find another number y which is greater than it? Yeah, because y also it is a real number. So for every x means you can take any number x in place of x. You can take any real number, square it, and add 1. Then for that result, okay, whatever the result here, can you find another number which is bigger than this, greater or equal to? That is true. And choice C, there exist x and y. There are two numbers x and y, or we can find two numbers x and y. Necessarily y is bigger than or greater than or equal to x squared plus 1. This is also obvious. We can find two numbers. But the last one, D, there is a number x. Okay, fix a number x, square it, then add 1. This result is always for every y it works, because for all y means for all y, for every real number. Okay, this is the result is smaller, because y is greater or equal to means y is greater or equal to it means the result is always smaller than for every real number. May not work, it doesn't work. For example, if you take 0 in place of x, 0 squared plus 1 in 1. So every real number is greater or equal to 1. What about in place of y, take negative numbers? It's not, it doesn't work. So because for every y it says, so there is no number, so it doesn't work. That is false. The answer will be, it is D. Okay, so that these are some of the questions prepared for today. Hopefully you have got some concept how to solve, how to connect logical connectives, and the concept that you learned. Thank you for watching. Don't forget to share to your friends and subscribe.